China, in a historic mission to the moon, has uncovered something so extraordinary it has fundamentally shifted our understanding of Earth's celestial neighbor. This revelation, hidden beneath the lunar surface for billions of years, holds the key to unlocking one of the moon's most puzzling mysteries and opens the door to exciting possibilities, transforming the course of lunar exploration forever. Just under 2 years ago, China embarked on a remarkable mission to Oceanus Procellarum, the vast lunar mare often referred to as the Ocean of Storms. This lunar region, appearing as a colossal dark expanse from Earth, had remained largely uncharted. The China National Space Administration achieved a historic milestone by sending the Chang'e 5 probe to this enigmatic terrain, nestled near the towering Mount Rumpke, a monolithic mass extending 50 kilometers in length and reaching a mile into the lunar sky. The probe's mission: to collect lunar samples and transport them to the lunar orbital module using a robotic arm, ultimately ferrying these precious samples back to Earth. What's truly remarkable is that all of this unfolded within the span of a single lunar day, equivalent to approximately 14 Earth days. The significance of this endeavor lies in the unexpected revelations it has yielded, particularly concerning the long-standing lunar water mystery. This discovery challenges our previous understanding of the moon's history, revealing a wealth of water in the form of ice, primarily concentrated at the lunar poles where perpetual darkness reigns. This newfound lunar water resource carries profound implications for future space exploration, including potential support for human missions to Mars and the production of rocket fuel. The moon, it seems, still has many secrets waiting to be unveiled, making these findings nothing short of fascinating. Until recently, the origin of frozen water on the moon remained a mystery. Even more intriguing, ice had been discovered in sunlit regions of the moon by previous spacecraft, but the source of this ice had stumped scientists. Some speculated it might have arrived via asteroids or from previously unknown lunar water reservoirs. However, researchers from the Chinese Academy of Sciences, in collaboration with European counterparts, believe they have found the key to understanding lunar water's origins. The samples collected by the Chang'e 5 mission from the northwest of the moon contain microscopic impact glass beads. These beads, which likely formed at high temperatures following meteorite impacts on the moon, were found to contain trace levels of water. To be specific, there are approximately 2,000 parts per million of water in these crystals, which amounts to 2,000 kilograms of water per metric ton of lunar soil. This revelation suggests that the moon holds a massive reservoir of water in the form of impact glass particles, estimated at a staggering 270 billion tons. This reservoir dwarfs previous estimates, such as NASA's 2010 estimate of 600 million tons of ice at the moon's North Pole craters. These glass beads are relatively young, about 1 billion years old, compared to samples gathered during the Apollo missions and earlier Soviet robotic missions. They have been forming for the past 2 billion years, particularly during periods of intense meteorite impacts, akin to the one responsible for the extinction of the dinosaurs 68 million years ago. The water trapped within these lunar crystals appears to have been produced by interactions with the sun. Specifically, positively charged hydrogen atoms from the solar wind are believed to have infiltrated the glass beads and combined with oxygen within them. Further analysis of the various types of hydrogen atoms in the samples indicates that these glass beads can also release their hydrogen charge when exposed to high temperatures from solar radiation. Remarkably, the moon's water cycle seems to be governed by these glass beads, hinting at the potential for an alternative water source on the moon, which has implications for the search for life. Where there is water, there may be life. But that's not the only remarkable discovery they made. Scientists are ecstatic about finding a rare lunar crystal on the moon's surface. a discovery that could potentially provide an endless source of energy for our planet. This lunar crystal is composed of a substance previously unknown to science and contains a critical component for nuclear fusion, a process that harnesses the same forces powering the Sun and other stars in the galaxy to produce energy. This crystal, which was found in lunar basalt particles collected during China's lunar mission in 2020, marks China as the third country, following the United States and the former Soviet Union, to identify a new lunar mineral. Notably, this mission was the first lunar sample return since the 1970s, and it successfully delivered over 1.7 kilograms of lunar samples back to Earth. The crystal, named Chengdu Site Y by the Beijing Research Institute of Uranium Geology in honor of Chang'e, the lunar goddess in Chinese mythology, is translucent and incredibly thin, about the width of a human hair. It formed around 1.2 billion years ago in a region of the Moon marked by volcanic activity. What makes this crystal so significant is its high concentration of helium-3, a primary ingredient that could serve as a dependable fuel source for nuclear fusion reactors right here on Earth. Helium-3 is exceptionally rare on our planet, but it appears to be relatively abundant on the Moon. China's upcoming Chang'e 6 mission, set to launch in 2024, aims to collect the first samples from the Moon's far side, which is permanently hidden from Earth's view. While it's too early to determine the cost of extracting and transporting lunar crystals, it's expected to be a costly endeavor. Additionally, the challenge lies in obtaining the substantial quantities needed to fuel fusion reactors. Helium-3 has long fascinated scientists as a potential fuel source for nuclear fusion because it produces significantly less radiation and radioactive waste compared to other elements. Current nuclear fission processes in nuclear power plants generate radioactivity and waste, necessitating the reprocessing of spent nuclear fuel. Given the significant safety concerns associated with traditional nuclear fission processes, scientists have been diligently seeking an alternative method for generating nuclear energy through fusion rather than fission. Nuclear fusion has emerged as a promising solution since it doesn't produce radioactive waste, potentially making it a safer and more efficient source of fuel. Consider this: just 25 tons of helium-3, roughly equivalent to the cargo capacity of a space shuttle, could power the entire United States for an entire year. This incredible potential translates into an estimated economic value of $3 billion per ton of helium-3. The discovery has ignited a race among various commercial enterprises and nations, with space agencies all eager to mine the Moon for this valuable resource. It's worth noting that in 2019, China's Chang'e 4 lunar rover stumbled upon a peculiar gel-like substance while investigating the Moon's far side during Lunar Day 8 of its mission. This discovery diverted the rover's initial plans, and it worked with lunar scientists to investigate the strange substance further. Although it's still unclear what this colorful substance is, researchers speculate that it might be molten glass resulting from meteorite impacts on the Moon's surface. This isn't the first lunar surprise. Astronauts Harrison Schmitt and Gene Cernan were thrilled to find orange-colored soil near the Taurus Littrow landing site during the Apollo 17 mission in 1972. Lunar scientists later determined that this orange soil was created during an ancient volcanic eruption approximately 3.64 billion years ago. Notably, in January 2019, China's Chang'e 4 became the first mission to achieve a soft landing on the Moon's far side, opening up new possibilities for lunar exploration. As the mission continues, the lunar rover's travels reveal valuable insights into the Moon's history and the history of asteroid impacts on both the Moon and Earth, as lunar craters serve as a historical record of these cosmic collisions. For billions of years, asteroid impacts have been the primary force reshaping the Moon's surface. Unlike Earth, where geology and erosion have gradually erased most crater evidence, the Moon still bears the marks of these ancient impacts. These cosmic strikes, occurring in close proximity to both the Moon and Earth, share a common history. However, the Moon's surface displays the preserved scars of impacts that are billions of years old. These lunar craters, though smaller than a human red blood cell and known as microcraters, are scattered across the Moon's surface. The fine lunar soil, or regolith, is continually churned into a powdery substance due to the Moon's ongoing bombardment. This process, known as impact gardening, ensures that the footprints of the Apollo astronauts will remain visible for at least 1 million years. Recently, the hard landing of Japan's lunar lander, the Hakuto R Mission 1, was confirmed through photographs of debris taken by NASA's Lunar Reconnaissance Orbiter. This privately funded spacecraft, launched by iSpace, aimed to touch down in the Moon's Atlas crater but lost contact with mission control near its intended landing site. This incident prompted NASA to conduct a comprehensive analysis of the area and reinforce the need for expanded lunar exploration. By establishing a lunar economy and infrastructure, they hope to support NASA's Artemis mission and facilitate easier access to the Moon's surface. iSpace plans a third mission as part of its lunar exploration program, featuring a second lander that will deploy a rover in 2024, with the goal of providing frequent lunar trips starting in 2025. Despite the setback of Hakuto R Mission 1, the company remains committed to achieving a sustainable lunar presence and advancing the lunar economy. This mission's failure is seen as a valuable learning experience that will inform future endeavors. The upcoming lander and rover mission in 2024 hold the promise of even more exciting discoveries, aimed at enhancing scientific knowledge and lunar exploration capabilities. As scientists continue to probe the depths of space, who knows what other celestial wonders await us? One thing is for sure: the universe has an uncanny way of leaving us awestruck and forever hungry for more knowledge. So stay curious, keep looking to the skies, and remember, the cosmos is full of wonders beyond our wildest dreams.